Okay, take two. Let me try this again. This is my second take, by the way. The first one ended up with various words that were inappropriate. Fine. Some days, you just wonder. Anyways, the goals for today. Example with the quantitative response variable. So we've been looking a lot at response categorical variables, but now we want to look at a quantitative response variable. We're going to use the example of haircut prices. Now, if we were in class, we would do this live, and I'd have everyone record on the board what their haircut, how much they spent on their last haircut. And the question that we're looking at is, do women pay more than men for haircuts? And the answer is yes. Okay. Okay, no, I'm sorry. We're in statistics. I'd say generally yes, but I mean, okay. Is this a statistical tendency or is it always true? By how much on average do women spend more than men on average? So looking at on averages, how much do haircut prices vary within a sex as well as between sexes? And to investigate these questions, this is actual real data from a professor who asked students in her class to report the cost of their most recent haircut. And then the following parallel dot plots reveal the sample distributions of haircut prices for each sex. So as you can see, they're all recorded here. $100 here does equate here. You can't do a slide. You can't have this sliding back and forth if they're actually connected. So if you can see like 150 here, it will go to that 150. All right, so that's just good setup. What I'd like you to do is pause this video now and go through numbers 1 through 3. You should be able to do those really easily at this point. Okay, I'm assuming you did that. Really quick, the explanatory variable is sex, male or female. So that's our input. The output, so to speak, or the response variable is the haircut price. Now, a price of a haircut is not categorical. It is quantitative. Could it range anywhere between 0 and 150? Sure, it could go way higher than that. And yes, once or twice with multiple colors in my hair, I have gone a little higher than that. Shh. Observational study or experiment. Why? Observational study, no treatment was imposed by the investigator. We don't even have a random sample. So did the professor who collected the data make use of random sampling, random assignment, both or neither, and neither? Just literally ask members of the class to come up and record on the board what they had. Now, first of all, we want to compare and contrast the distributions of haircut prices between men and women in this class. Remember, we talked before about commenting about the center, variability, shape, and any unusual observations in this context. All right, so specifically looking at each of the distributions. You should give enough detail that someone reading your comments could recreate the overall pattern of the graphs from your description. Now, we're not talking numerically recreate here. We're just talking general shape-wise, all right? So, for example, just before we get into it, if I looked at men, I would say that, it has some outliers, and we can see them, hopefully you can see them out here, and we're going to talk more about this, but you don't have to say precisely 0, or it's more in general. Okay, so what we see in general, I'm just going to look at these two for number 4, excuse me. Where roughly would you say the center for the haircuts for women? So, because it asks specifically for center, variability, shape, and unusual observations. So let's look at women first. Looking at this without doing any calculations, I'd say the center is right around 50. Now that's approximate. We haven't done any calculations yet, but I'm just saying the center is about 50. Remember the squiggle, not quite equal sign is approximately, so that's $50. And if I'm comparing it right now, so I'm going to do the men's at the same time. The center for men, on the other hand, I would look down here and I'd say that's probably around $20, roughly. Okay, on an exam, if I asked you and it was a pick one from the list, would I give you numbers that were really close where you had to choose between like $24, $23? Definitely not, okay? I would give you either a range with an acceptable, well, don't worry about it. In other words, I wouldn't give you something that you couldn't answer. If I was thinking, you were thinking, well, I thought that it was more like $21, that would be acceptable. All right, so men, I'm just gonna say it's about $20. Variability, who would you say had more variability? What do you think? Variability is a lot larger for women. If you look, it's really scattered all across here, okay? So variability is large. And for men, I'd say the variability is compared to women is small compared to women. Shape. Let's take a look at the shape. Do we see any, I'm just going to erase all these lines here so you don't get confused. Let's talk about the men first. Do you see a skew? Hopefully you think right away, yeah. It's those, that $75 is definitely going to pull up our average, right? So it is, the men is skewed right. Is skewed right. What about women? Yeah, I would definitely say they're skewed right too. You've got these observations out here that are definitely going to pull up our average because most women are, you know, a bulk are right in there somewhere, but then you've got those $150 haircuts that are definitely going to pull up. So the averages, so it's skewed right. Remember, it's skewed in the direction where there's weirdness. All right. And then unusual observations. So unusual in the context. So I'm just erasing here. In the context, what would be, you think would be unusual for men? Well, I think unusual for men would be more than $50 because there's just a few of them. So unusual for men, unusual is more than $50. How about women? Women, the unusual ones were about $150. Because we don't know, they put them here, so it's about 150. Or you could just say $150, that would be fine too. So when I pulled that together, you may have thought, well, we'd have a lot more written down, but really no. It's just talking about those keys. Remember, whenever we're talking about specifically a quantitative variable, we want to look at the distributions and hit all of these points, okay? So we've looked at the distribution, we found that they're right skewed because there's right stuff happening, There's extreme observations, and the average for women is higher than the average for men. So let's keep going. Let's further explore the data. Explain why the right skewedness of these distributions makes sense in this context. Well, honestly, what it comes down to is most people looking at it here in general, we can even think about it. A lot of people don't spend a lot on haircuts, but there are some people, it does vary a lot, especially for women, that have more sophisticated haircuts or hair colors are going to spend more. But some people don't spend any money on haircuts. So we expect a lot of variance, and we expect that there's going to be some who are going to pay a lot. So I just wrote, most people don't pay a lot, a few do. Now, on the other end, explain why the unusual behavior at the lower end of the dot plot, several values at 0, and then a gap to the next smallest prices makes sense in this context. Well, I can tell you right now, especially in my home, my husband has been doing my hair. And so what you see is letting me grow out the top and him buzzing the sides. Okay, I do his hair all the time. So I would expect, there's going to be people who just do it at home. We have clippers. Now, do you expect there to be a $1 haircut or a $2 haircut or a $3 haircut? No, I mean, Great Clip sometimes runs deals for like $8, but those are even pretty unusual. So it makes sense that there's a gap here. So looking back, to explain that unusual behavior, family or friend cuts it, it's going to be $0, but a professional, a minimum is going to be up, let's say roughly $15. So based on the dot plots, without performing any calculations, make a guess for each sex's mean haircut price. Take a second and see what you think. So to make my guess, I personally went up here to the distribution and to take a look at them. And I said, well, men seem to have a lot right around here, and I'm going to guess that's about 20. Women, whoa, they're really kind of all over, but I'm guessing the average right here would be about 50. So that's what I recorded down here. Based on the dot plots, without performing any calculations, which sex do you think has the larger standard deviation of haircut prices? Now, standard deviation, remember that's a measure of variability. Take a look at your dot plot. Who has more variability? Well, women, we've talked about that as we've gone along. The data is much more spread out. So there's larger variability. You can use the descriptive statistics applet to calculate the mean and standard deviation. I ran the applet to get the numbers. You just need to either copy and paste in the data into this applet, and it will actually calculate the mean and standard deviation for you. Or you can do it on your calculator. A lot of calculators have that as an option. As a general rule, we won't probably be using descriptive statistics, that applet, all that much, not compared to the other applets we've used. But I ran the numbers, and so we want the sample size, mean haircut price, and standard deviation, this is for part A, of haircut prices for each sex. Include the appropriate symbols and measurement units. So take a moment and think about what symbols you would use, and then start back up. So I wrote down, if you want to pause and write this down, and then start again, the numbers for men and women. N is the sample size, and that's listed above. It's given to us, 13 and 37. The mean, we think of the mean, I just wrote this out in letters. You notice that I could have also said, in words I should say, that would be X bar men, let's say, and X bar women. Not too worried about that right now. That's kind of a side note. It did say use the appropriate symbols and measurement units. But honestly, writing mean in this case would be totally acceptable. Standard deviation, and oh, if you're curious how you would know when it's appropriate, I'll make it very clear when I want to use X bar, etc. Standard deviation, we usually just use SD. Sometimes we do use sigma, but you have to be careful because remember sigma is for what? Leave you with that for a moment. Standard deviation is $22.14 for men and $41.61 for women. So do these numbers make sense? Well, yeah, everything we've talked about before, it makes sense. We thought the average for men was about 20. The average for women was about 50. We were pretty close. Standard deviation we expect to be bigger for women than men. So which sex has the larger mean haircut price? Is that what you predicted? It's women, and yes, we did. And which has the larger standard deviation is what we predicted in 7. And once again, it's women, and yes. And as we go along, we'll be using more of right now we're more trying to get to understanding the mean and standard deviation. We'll use a lot more with the symbols as we go along. But if you're trying to remember to pull out which symbol was which and why I said sigma, take a look at your sheet. and to refresh your memory. All right. So would you conclude that these data show an association? We haven't used that word too much. A relationship is what we're looking. Relationship, are they somehow related between the haircut price and a person's sex? If so, describe the nature of the association. So I'd say yes, there appears to be an association. We haven't done any statistical analysis per se yet. All we've come up with is the mean and standard deviation of each. But yeah, there appears these data seem to show an association, some sort of relationship between haircut price between, sorry, I should have said sex and haircut price. What do I see? If so, describe the association. The way I describe it is women tend to pay more for the haircuts than men. I should say. All right, so let's return to the research question that we started with. This is number 10, and address these questions based on the previous graphs and statistics. So take a look back. Do women tend to pay more than men for haircuts? If so, is this a statistical tendency, true on average, or always true? What do you think? I'd say yes, women do tend to, there's statistical tendency to pay more than men, but it's not always true, okay? Why would I say that? You're like, but the average is higher. Go back and look up. There are women who pay 0, and there are men who pay 75, right? So it's not always true, but on average, women tend to pay more than men. By how much do women spend more than men on average? All right, so this is when we're going to start talking about looking in at that difference, like we did with the categorical data. Remember, we take the difference of the B hats. So you'll notice that suddenly pops up. We saw on average that women pay $54.05, men pay on average $21.85. So the difference on average is $32.20. So we do see that there's quite a difference there. So let's talk a little bit more about that difference. Do the unequal sample sizes between the sexes lead you to doubt whether any conclusions can be drawn from these data? Explain. Well, honestly, you're like, well, yeah, the sample size are quite a bit different, but because there was 37 women and only 13 men, but the means are so far apart. $32, that's quite a difference between 21 and 54, that even with such a small number of men, which you want to keep in mind, the difference in the means is still large. So I just wrote down the means are far apart. So we want to keep in mind that we want to keep the small number of men in mind, but the difference in mean is still large. It's a big number, all right? So it's definitely something that we would want to investigate. Based on how these data were collected, would you feel comfortable generalizing your results to the population of all college students in the United States? How about the population of all college students at the professors' universities? Explain your answers. And I'm going to say no. Okay, I wouldn't be comfortable. What's one of the things that we would want? Well, a random sample. Is this a random sample? No. While the sample may represent students at the university, we need to be pretty careful when generalizing this, since it's not a random sample. So there's no guarantee that this is representative of our university overall. So I just wrote down, no, not a random sample of any population, and there's no guarantee that that sample that we have is representative of our school. So we can't say much about anything there. Based on the differences in centers and the amount of overlap in the distributions of haircut prices between men and women, do you predict that the difference will turn out to be statistically significant? And we're going to learn how to assess this statistical significance in the next session. Personally, yes, I say probably it is. Because that difference in means is pretty big. Okay, now the individual values of the haircut prices we've been analyzing were given. So they're listed out. You'll notice, you know how remember before we can find median or do anything with the quartiles, we need to have them listed from high to, low to high. You'll notice that that's already been done for you in this chart. All 37, if you count it up for the women, there are 37 observations here. And for men, there are 13. The median is the middle value set once the values are arranged in order. The location of the median can be found by calculating n plus 1 over 2. Well, I didn't talk about that last time, but I would like to talk a little bit about what if you're struggling with how to find the middle or the first, where the first quartile is or the second quartile. There's actually a easy formula that I don't have in the notes, but I'm just going to jot at the top here. Okay, you're going to notice, you may want to pause for a minute and write this down, or have me talk it through, then pause and write it down. But how can we find which value to look at? The first quartile value, why I'm doing it this way is to show you that this actually makes sense. We want the first quartile, so we're going to look at n plus 1 value. So whatever your sample is, you're going to add 1 and divide by 4. Multiply by 1/4. All right, because you're looking for the first quarter of it. The second quartile, the median, is going to be 2/4 of n plus 1, that value. Now, it's not going to be, you're not going to say, well, that's where you're going to look for the value. You notice that 2/4 is the same thing as 1/2. Okay, and that's where that median will be. Okay, the third quartile, where would that value be? It's at 3/4, because we're looking at the third quarter, really, of n plus 1 value. So you want the value at whatever spot it is, all right? So if I think about it that way, I want the median. Let's say, let's do it first of all by doing it the easy way. I have 37. Halfway between 37, well, there is no exactly halfway. It's, let's see, 15 and 15 is 30, no, 16 and 16. Oh, how about 18 and 18 is 36? So if I go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. I know that because 18 plus 18 is 36, right? So I know that there's 37 values. So right in the middle should be my median. Would we agree, hopefully? Let's see. I'm just going to count the last, make sure there's 18 after that. So I make sure I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. Okay. So I see quickly that the median price for women is $45. Median, remember, it's not the average, it's that middle value. Well, what if I want to use this formula that I came up with? To keep it simple, I'd say, okay, I want to look at the value for the median, the second quartile, because that's the middle. And I'm going to do 2/4 n plus 1. So I know that simplifies to 1/2. And I'm going to get, let's see, 1/2 of 38, which is going to be the 19th value. So 19th value, what I want to do is count and take the 19th value. Remember, they have to be in numeric order. So I'd count, if I just Let's see, I'm going to erase what I have here. Probably should have done this with the men, but you know, why not? Count 19th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There is our median. That's the 19th value. All right. So we get the same answer. So one's more mathematical way to do it. The other way is looking at it, knowing you need to go to the center. They both work. All right. How about the median haircut price for men? So I've got 13. So I think, well, halfway between 13 and 6.5. So remember, you could do the n plus 1. The way I think about it is like, okay, if I go halfway between, I could have 6 and 6, right? Check to make sure I'm right there. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oops, nope. 6 and 1, 2, 3, 4, 5, 6. It's very easy to make a mistake, so be careful. That median value there is 20. Which sex has the larger median haircut price? It's women. Is it what we expected? Yes. Number 14C, are the medians less than or greater than the means? Is this consistent with the right skewed of haircut prices? Explain. Are the medians less than the means? Take a look back. Hopefully you say, yeah, they are. The means are less than the median. Excuse me. Let me try that again in English. The medians are less than the means. Oh, I decided I need to pause and write instead of trying to write and speak at the same time. Bad things were going to happen. Okay, the medians are less than the means. That makes total sense because remember, the data is skewed to the right. So those high outliers pull up the mean values. If you're still not sure, look, remember we found the median here, and you scroll up a little bit and we have those mean values. All right, scroll up a little bit more. Ah, yes. The mean for a woman was $54, mean for men was $21.85, and our medians were both lower. Okay, so if you want to double check that for yourself, of course, you could always add up all the numbers for the women's haircuts to find the average, just to confirm that to make you more comfortable. You do the same thing for the men and then compare it to the median. So one way to summarize the distribution of quantitative variables such as haircut price is by dividing the distribution into 4 pieces of roughly equal size being the number of observations. In other words, summarize the distribution by determining where the bottom 25% of the data are, the next 25, the next 25, and the top 25. All right. The one nice thing about going this way is it isn't when you look at like median, which is that the very middle, it wasn't pulled by those outliers. So exploring the data using quartiles in the 5-number summary. Okay. We want to calculate the lower quartile for the women's haircut prices. So just like we did before, first note that the median is the 31, like we did, found that 19th ordered value. The lower quartile is the median of the bottom 18 values, which is found. So they did it a slightly different way. Instead of looking at all the values, they said, well, we're going to segregate those 18 values by themselves and then find the middle position there. Okay, you can either do it this way, like they did here, by looking strictly at the 18 values, or you can do it the overall way by saying the total times 1/4. You will get the same number. All right, so the lower quartile is the average of the 9th and 10th ordered values. It's very important to think ordered values. So let's go, let's see. I'm going to first of all erase stuff here, make it a little bit easier to look at. Let's see, it says between the 9th and 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's the average of those two together. So the average between them would be In this case, in this instance, I'm going to call it quartile 1, and it's going to be the average of the 25 plus 20, and that's going to be 2250. What about the third quartile? So let's use, you can use whatever method you like. I'll be honest, let's do the easy method for just looking. So we know that we have 37 values. So we have an odd number of values, right? So there has got to be a center value in the middle of this, and it was. Remember, we went to 16 and then 16 and we got to 45. So we looked at the first quartile. Now I know this was my center 45. So this is going to be where I'm going to find the middle of this second set will be where my third quartile is for the women. So it's going to be, let's see, there were 18. So it's going to be between the 9 and 10 again, which makes sense, right? Because we have 18 values, and like we found before, the middle of the 18 will be between the 9th and 10th. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10. Ooh, what's the average of 9 and 10? $70. So that makes that easy. So you should figure out a method, whichever be numerical or literally sitting and counting, that makes the most sense for you. So take a moment and calculate the lower and upper quartile for the men's haircut, and then check your answer. Okay, so hopefully you came up with that. Now, report the 5-number summary for the women's haircut prices and for men's haircut prices. The 5-number summary, the numbers that you want are the minimum, the lower quartile, the median, so the middle, the upper quartile, and the maximum value. All right, so those are 5 numbers. Take a moment and see if you can fill in this chart and check your answers against mine. So this is literally just gathering the information together to put it in one spot, which is really helpful just to see it. It gives you a better sense for how the data differs and looking at the spread. But what's actually even more helpful for that is number 17. So in the applet, I personally generated the box plots. So to overlay the 2 box plots as well. I generated the box plot. Oh, I used an applet to get here. Describe what the box plots reveal about the distribution of haircut prices between men and women. Now, visual is always good, right? It's very helpful. Do these things line up? Yes, they do, all right? I look at it and I immediately see that which one is more spread out? Well, the women, all right? The women's haircut, what they spend is definitely broader. Look at, we can see that right here. The men's is much shorter here. The 50%, we know exactly, middle 50 is right in there, which makes sense based on looking, I have the dot plots below them. The interquartile range, so the IQR, makes sense that it's bigger because it's more spread out, all right? So it gives us a lot of good information. So let's do some calculation. Find the IQR, so that interquartile range for both men's and women's haircut prices. Take a moment and give that a shot. So remember, the IQR is another way to look at variability, and it is not pulled as much by outliers as the standard deviation is. So the women, the interquartile range is 47. Okay, well, I almost had a breakdown there when all of a sudden the screen went white. Whoa. Okay, we're back. Think everything's good. Oh, I hope so. We're so close. All right, so we looked at the interquartile ranges, and the women's is still larger than the men's. Does that make sense? Yes, because remember, there's still more variability among the women's than there is among the men's overall. So final question, if we remove the male haircut price of $75 from the data and in the applet, find the new standard deviation IQR. So I took care of that. Compare them to the values you had earlier and confirm that this illustrates that IQR is more resistant to extreme values than standard deviation. So the new standard deviation for the male haircut prices was $16 once I took out that really big one. Before it was $22.14, I think. And the new IQR is 14, and before it was 15. So just by pulling out one value, we see that that had made a huge difference in standard deviation. On the other hand, the IQR, the interquartile range, not nearly as much. It only changed by $1. So obviously we see that standard deviation changed substantially more than the IQR with the removal of the extreme male haircut price. That's the end of this example. Tomorrow we will work more with response variables, being quantitative, I should say.